Now we are going to see one more problem, that is we are going to see one more problem, that is in Jacobian matrix when eta and epsilon values are not given, and that time what you have to do, how do you get the Jacobian matrix when eta and epsilon are not given? This is the formula, this is the diagram. Their coordinates are given at the 4 points of this quadrilateral element. This is the coordinates I have written. The shape functions for isometric element n1 1 by 4 1 by epsilon in 1 minus eta 1 by 4 1 by 1 plus epsilon 1 minus eta 1 by 4 1 by 1 plus epsilon 1 plus eta 1 by 4 1 minus epsilon and 1 plus eta. So these are all the formulas to find out the shape functions. Now V doesn't have these values. So now what should we do? If we have the D solid, directly we substitute and we get the N1 and N2, but we don't have. So now what we are going to do, we know another X is equal to, that X is equal to, we know N1, X1, N2, X2, N3, X3, or what is this? This is a Cartesian coordinates that eta and epsilon are local coordinates. So these are the Cartesian coordinates value. Now I'm going to substitute, because I'm going to transfer the Cartesian into the local coordinates. I'm going to substitute these n1, n2, n3, n4, n4 shape functions value in this. That is what these values should be substituted here in in x and y Cartesian I substituted n1 x1, that is n1 is this one into x1, n2 is this one, this is x2, n3 is this one, this is a value I have substituted, and x and y I got x and y, this is the value, and everything I have substituted the value complete. X1, X2 are given, so no need of worrying about that. X1 is 1, this is 2, this, so I got this. Now simplify this. You multiply this and this, you multiply this and this, you multiply this and this, and abbreviate it, expand it. That is what it is. So inside you multiply and you got this value. Then you constants alone you add, eta alone you add, and epsilon alone you add, you got this value. So one thing we will see, so 1, 2, 2.5, 1.5. So you add this, you will get 7. So how many etas are there? That's how many, only one etas are there. So this is the way you got this. This is simplified. Just you got this. Now x is equal to this one. Now we have to differentiate this one. This is J11. When you differentiate the x coordinates in terms of eta or epsilon, you will get the J11 Jacobian matrix of the first value, that is J11. So you differentiate with respect to epsilon, these goes constant, these goes only here, the 2 value remains, because you are referring epsilon, so 2 by 4, 1 by 2. And again, when you differentiate this one with eta, then this only exists, these 2 will go, so this 1 is 1 by 4. Now you got dou x by dou epsilon and dou x by dou eta. Now we have to find out the y value. What is that y value? So y value, this value you have to substitute it. I got this value. After abbreviating and multiplying inside, I get this value. So now constants eta and epsilon are segregated and you got this value. So now this is the maximum you can simplify. So now we can differentiate with respect to epsilon in the y-axis. So I got this value, I got this value J21 this is, and I am differentiating dy with respect to d eta. So I got 0.15. So these 4 values are what? These 4 values are taken out. These 4 values, that is J11 dou x by J12 dou y by dou sigma, J21 dou x by dou 6, do away by do. So substitute this is value, you got the Jacobion matrix. This is the problem describes the when the coordinates of eta and epsilon are not given. At that time, what we have to do? Step is that you transform everything into the Cartesian coordinate into local coordinates by substituting the n1, n2 values in the Cartesian formulas. From there, you expand and simplify, and after simplifying, you differentiate with respect to eta, you differentiate with the epsilon, and the same thing in the y coordinates, differentiate the epsilon and differentiate the epsilon. So you will get J11, J12, J21, J22 value substitute here, and you got this Jacobian matrix. This is the way you have to do it.